Hello, differential equation students, and welcome back. This is still Unit 5. This is video, or 6.3, I should say. And this is video. Technically, I'm still calling like this video 2. We call this B because we're going to finish this problem. Okay. This is where I left off last time in my last video. And what we're going to do now is we want to think about how to solve this. Well, it's equal to 0 over here, right? So this portion right here has an x to the r minus 1. Well, I see I see 0 x to the r minus 1's over here. So that means that this portion right here, this 2c naught r times r minus 1 plus c naught r has to equal 0. It does. Has to equal 0. And what I need to do is there's a couple things going on here. One, I see the c naughts, right? But those are just constants. So if it's a constant, I should be able to I can factor it out even better. I could probably just divide it completely out, but I do see that this is 2. This is a c naught r. They both have c naught r, so maybe I'll just slowly do this. That leaves the 2 in here times r minus 1 plus 1 equals 0, right? Well, remember now, this c naught is just a constant, so I should be able to easily divide that. Then I would have 2r minus 2 plus 1 is a minus 1 here, equals 0. I get r equals 0 or 1/2, right? So you can see that I found 2 roots just by looking at this one up here. Well, this creates 2 different r values, okay? It creates 2 different r values. I'm going to get there here in a second, but that right there shouldn't have been too bad. Now looking at the blue part, right, this blue section, same type of issue here. I see 0x to the k plus r's here, right? So no matter what I have for k, each one is going to be 0, so I should be able to just set this thing equal to 0. Well, by this thing, I mean this entire show right here, right? And just remember how we wanted to do this before. We want to get the c sub k plus 1 in terms of everything else, right? So if I were going to do this, I would first have to move this over, right? So it'd be like a negative c sub k here on top, and then it would be times k plus r plus 1, right? Because I can just add those. And then on the bottom, I would have, okay, well here, this is where it's super helpful. You see that this has a k plus r plus 1, so does this one, right? So maybe I'll take that out. That's a k plus r plus 1 times, well, what's left then? It's a 2 times k plus r. And now it's plus 1, right? Don't forget that there is a plus 1 there. And of course, I've placed it on the bottom because I have to divide it over to get this thing by itself. I see that these cancel out beautifully, which just gives me a negative c sub k over a, well, I can do a couple things. One, I can just factor this through and push it through. So this would be a 2k plus 2r plus 1. Okay. And that is my c sub k plus 1. Okay. So here, what's happened though is I've gotten 2 r values. So because there's 2 r values, it's like I have like 2 cases. So let's do it for each case. If r equals 0, then my new one would be c sub k plus 1 equals, well, it's a negative c sub k up top. That's not going to change for me. Now r is 0, so this cancels out, and it's just 2k plus 1, right? Now where does k start out at? Well, k starts at 0, so I start here at 0 for my k, which if k equals 0, then I would have c sub 1 equals, well, that's negative c sub 0 over, that's a 0, so that's just a 1, which is a negative c sub 0. Then k equals 2. This is where, remember, we've done these a couple different times, that we just work them out, right? This is a negative c sub 1 divided by a 2 plus 1, which would be a 3 here. Well, I know that c sub 1 is negative c sub 0, so this is like a negative 1/3 times a negative c sub 0, right? Which would equal a c sub 0 over 3, or 1/3 c sub 0. It doesn't matter how you want to write it. Let's do one more here. This would be a c sub 3 equals, well, this is a negative c sub 2 now, all over, this was a 4/5, right? And then I would have a negative 1/5 times, well, negative c sub 2, oh, I'm sorry, I put that negative on the negative 1/5. So c sub 2 was, well, c sub 3, or I'm sorry, c naught divided by 3, which is 1/3 c naught, which would then give me negative 1/15 c naught. Okay, and what you can kind of see is, you can see this pattern emerging, right? And each one is going to have this c naught in it, right? It has this c naught sprinkled throughout it. So when I go, we can call this like the first one, y sub 1, because we've done that before, of x would be the c naught. Well, what would, oh, that's right, we would have it as x to the, remember, all the way up top. In fact, because I have my notes out, remember, this is supposed to be the solution, right? So my c naught is 0, or my c sub n is 0 here, and then that makes, remember, r we were having was 0, right? So that's also 0 for this n, right? So it's x to the 0, basically. And just for completeness, since this is our first time, I'll write this 0 in here. It starts with the 1, then it's minus, because of this negative, oh, and then it would be c sub naught, this would then have the x, right? Because it's c sub 1. Right, are we seeing this here? This would be a negative 1 for the coefficient because of the c sub 1, x to the first. Then I just keep going. Well, it would be plus 1/3. This is a 2, so this is x squared. Then I would have, oh, okay, this is x cubed then with this one. So this would be a minus 1/15 x cubed, and then so on. Now, that was just for the r equals 0, but we know, right, from above there, that we also have to do this thing for my other one. So if r equals 1/2, then, well, now I need to create this one again, right, my c sub k. So I have my c sub k plus 1 equals a negative c sub k up top still, right? And then it's divided by, well, let's see here, if it's a half, right, if it's a half for r, that would make this r just a 1. So it's 2k plus 1 plus 1, which is just 2k plus 2, right? And now we're just going to go through, I'm going to do the same type of thing. So we'd have k equals 0. If k equals 0, then that's c sub 1 equals a negative c sub 0 divided by, what, 2 there, equals negative 1/2 c naught. Then I have k equals 1. That'd be c sub 2 equals negative c sub 1. A 1 there would make it a 2 and a 4. Okay, so this is a 4. That's a negative 1/4 times a negative 1/2 c naught, which gives me a 1/8 c naught. And I did one more up there, so I might as well do one more down here. That's c sub 3 equals negative c sub 2. And this would be a 4. That's plus 2 is 6 here. So that's negative 1/6 times a 1/8 c naught, which would make a negative 1/48 c naught. All right. And it's just really important that you're getting the rhythm here that, okay, this one would have x because of this 1. This one would have x squared. This one would have x cubed, right? Would have x cubed. Now, the tricky part here is this one was c naught x to the r. That's actually what that was. It had this r up here. And this r was 0, so it's a 0 here. But now it's not, it's no longer there like that. This y sub 2, right, of x is going to be equal to, well, these still all have this c naught, and then it's x to the 1/2, because that's what our r value was. And then it's times, okay, well, it'd start out with just the regular old 1, right? And then the next one is this x, because it's x to the 0 here for my c naught. And then x would be that negative 1/2, and then it's x, right? And then I just continue, right? I have this plus 1/2. This shouldn't be too bad. X squared plus, oh, I'll mess that up. It's not plus, it's minus 1/48. And that's x cubed, and then so on. Now, the issue that you're going to have, and I know you're going to have it, is because we have this c naught, and you think that they're the same. Remember that they're fundamentally actually different because they're at different r values here. So it's changed the constants. It's okay to do it just like we've done it, but when we put it all together for our final answer, we're going to want to distinguish the fact that those c's are different. And I think each textbook's a little bit differently. You can do C1 and C2. It doesn't really matter to me. Here, I think a lot of people introduce like D as my constant. Now, because it's a 0 here, this top one, right, is just x to the 0. I'm not even going to bother putting it, but you could put it in there. It's just not typically how we would do it. 1 minus x plus 1/3 x minus 1/15 x squared, so on. That was our y sub 1, and then we add in, okay, now this c naught is different, so it's d sub 1 x to the 1/2, and then times 1 minus 1/2 x plus 1/8 x squared minus 1/48 x cubed, plus so on until the end. And there we have our first singular or power series solution about a singular point. Okay. If I have enough time, I will be making a second video. Okay, I will be making a second video over another example, but you should not necessarily count on that one.